thank you, everyone. Let me just extend a huge thanks to all of you for making it your way over here to the Venetian from the Convention Center or wherever else you may have been to join us for our inaugural Intel Automotive CES keynote. So it's really an amazing time to be in the automotive industry. But I know a lot of you might be thinking, why Intel? What do we have to offer? And why now? Why is this the right time for Intel to help the automotive industry?
Intel Automotive is committed to accelerating the automotive industry's successful transformation towards a software-defined, sustainable, all-electric future at scale. Offering a best-in-class scalable product portfolio supported by regionally resilient manufacturing, all underpinned by decades of industry transformation experience. We have a special guest today. He is Jack Weast, Intel Fellow and Vice President and General Manager of Intel Automotive. He's actually calling from China today. So glad to have you, Jack. How are you today?
I am great. Very happy to be here. We'll probably talk about it. I've been living in China for the last month. This was a public holiday. So my first vacation in China, in the South Sea of China on Hainan Island in Sanya. So for those that haven't been, it's a beautiful place. Would highly recommend it. So I'm doing great because I'm on vacation. So how about that?
Yeah, well, thanks for carving out your vacation time to talk to the Ojo-Yoshida Report. I really appreciate this.
Of course, shows you how important it is.
This whole idea of starting out this Dig Deeper series on software-defined vehicle actually came from you. When I first talked to you late last year, you actually made a pretty provocative statement that, a lot of people are talking about software-defined vehicles, but they're not done right. And it was more of a marketing, branding rather than actual technical solutions. So I said to myself, all right, well, let's see what Intel has, but also what Jack thinks. What's wrong with the software-defined vehicle that you see on the market? So let's start from there, okay?
No, thank you. I appreciate the question. I deserve to be called out on it for sure. So I think the first thing, as you know, I have a technical background. So I've been fortunate to have a great technical career at Intel and now running a business. And so that technical context has shown to me where I've learned that the software-defined architectures, they're not features. Over-the-air update is not a feature of a software-defined architecture. Yeah, it's something you could do, but the most important thing is that it's a mindset. It's an architectural philosophy where you need to think about compute resources completely differently. And what I mean by that is thinking about compute resources as just pools, amorphous blobs of memory, compute, I/O, acceleration, from which, through the magic of software, you can form and define and create a platform out of that amorphous pool of resources. So that's the fundamental foundation of what software-defined architectures are and why other industries like industrial and telecommunications have embraced it. Because as general purpose compute gets good enough with the beauty of Moore's law, you now have a platform that's capable enough that you can then define it in different ways using that architectural mindset. So that's the most important thing I think about software-defined architectures. And I think something is really fundamental that I think a lot of people miss when we talk about it in the context of vehicles.
That's actually a very important point because I was talking to one of the analysts the other day. I told him that I think I fundamentally misunderstood software-defined vehicles. Several years ago when I first heard it, oh, you're talking about over-the-air software updates, right? So this actually, you kind of redefine it with software-defined architecture. That's interesting. But, when you think about SDV or software-defined vehicle in this context, what problems in automotive do you think you're solving?
Yeah, it's a great question. And that's where the motivation, why is the right time for the automotive industry to embrace these kinds of architectures or really this new architectural mindset? And that is, the vehicle as architected today, based around fixed function, lagging node microcontrollers, with dozens up to 100 ECUs per vehicle, a mile of copper cabling. The price of copper used to be 66 cents a pound, in the early 2000s. I think it hit over $5 a pound a year or so ago. So the basic vehicle architecture has hit a wall, both technically, because sometimes there's physically not space for more boxes, and these lagging node microcontrollers don't really provide the performance headroom to bring new use cases. But frankly, and more worrisome for the automotive industry, is economically. It's difficult to make a vehicle platform at a profit. And I think this is a big contributing factor to why we don't see, the $20,000 vehicle much anymore, in established markets, because of all that copper, all that compute, and the cost of those raw materials just keeps going up and up and up. So it's really both technical limitations and economic viability concerns that are driving an important rethink of how should we think about the vehicle architecturally.
Yeah. All right. But then again, well, you use the software-defined architecture, the define it, but it's the software-defined phrase is used for things like vehicle software-defined sensors. Or I even heard, I think it was Intel that was reading your blog or something. It just talked about the software-defined MCU, right? So that was, I think, in the context of Intel's acquisition of, I think it's a French company, Silicon Mobility. So tell me about those different, especially actually, I'm interested in software-defined MCU stuff that you talked about. Yeah.
I'm glad you asked, Junko, because it's that software-defined mindset from an architecture standpoint is not limited to just the high-performance compute systems. Why not extend that pool of compute resources, not just from the high performance, but also to low performance microcontrollers or zonal controllers? And so then when you're partitioning a virtual platform or virtual resources from that pool, those resources can span microcontrollers and high performance compute systems. And this is really the same way it works in the data center. When you think about a rack of servers, you've got 12 blades or something in a rack, and each blade could have 2, 3, or 4 sockets of compute. When you're defining a software-defined architecture in a data center, that whole rack is your pool that you can allocate from. So why not think about the whole vehicle and all the compute resources as part of that pool that we can utilize and define our software-defined architecture? So that's what we mean. And the acquisition you mentioned brings some technology to Intel that will allow us to do that for our customers.
Interesting. Just so that I'm understanding this correctly, is Intel today in the embedded MCU market for the automotive at all?
Yes, as of about 2 months ago when we completed our acquisition of Silicon Mobility. So Silicon Mobility's primary product line is in the context of EV powertrain. They deliver a very unique microcontroller device that delivers significant improvements in energy efficiency and lowering costs significantly as well for energy delivery solutions. But the elements of their architecture, which is fast, deterministic, and software-defined concepts that make powertrains much more efficient, can really be applied to any workload. So we're using their technology to not only offer electric vehicle power control devices, but also software-defined zonal controllers. And so Intel today is the only supplier, we believe, that can provide not only the highest performance HPC systems, but scale all the way down to micro and zonal controllers as well. And this is what allows us to take this whole vehicle architecture mindset and truly embrace software-defined for the whole vehicle, not just one socket.
Interesting. So this actually leads into my next question, because I didn't quite understand how the Silicon Mobility piece fits in the puzzle. But from, I talk to a lot of chip companies, generally speaking, and it seems like everybody has a different place where they think they're very strong and they want to move on to the software-defined architecture. For example, Qualcomm has its own idea, NVIDIA has its own idea, usually more focused on the infotainment or the ADAS functions, while companies like NXP are looking at, okay, we're not going to touch that. For the time being, we're going to focus on the real time, operations that are needed in this software defined vehicle. So did you just say that you're going to span the whole thing? I mean, what are you looking at when you say software defined vehicle?
Yeah, you said it right. That's what we're going to do, because we think, to really deliver on the true promise and potential of software-defined architecture, you have to consider all the compute resources within the car. And so to do that, you have to include everything from microcontrollers to power devices to high-performance compute systems. And so with our acquisition, we think it uniquely positions us to be able to do that, because as you noted, others in the market might have the high-performance piece. Others in the market might have the microcontroller piece, but nobody until now has both. And so that's what we hope to really do, is affect a really significant change in the industry with the breadth of our portfolio that spans the whole gamut.
All right. That's interesting. Although I have to say, some people might argue, like companies like Renesas. I just talked to them last week, and they said, "No, we span the whole thing." I mean, everybody wants to say that we span the whole thing.
Sure. No, absolutely. And competition's good. We welcome
Yeah.
it. And at the end of the day, to be honest, the important thing here, I think, is really for thinking about the industry as a whole. We really
Yeah.
need to help the industry move forward and fix this broken up economic model. It's because of a broken architecture, and so we welcome others that have similar solutions, because that means we're all working together, providing multiple options for choice and really helping lift all boats, for the good of the automotive industry.
All right. So let's talk specifics, right? Which hardware is your software defined vehicle architecture solutions are based on? In other words, that we haven't really seen much of the details, what hardware Intel has. So just spill.
Sure thing.
Tell us.
So at CES, we announced our first generation family of AI-enhanced software-defined vehicle SoCs. And then we just talked about the Silicon Mobility acquisition that brings microcontroller and zonal controller class compute devices to that.
Yeah.
But for the traditional kind of Intel offering, what we're doing is we're taking the best of Intel's AI PC technologies and the best of Intel's data center technologies, where we support things like hardware virtualization, and bringing those things together in a lineup of products that are ready for production this year. And in fact, we just announced in China partnerships with both Newsoft, a very well-respected Tier 1, as well as Thundersoft, a very well-respected Tier 2, who are both building solutions around those products. Zeekr was already previously announced to be the first to commercially deploy. We'll be ready this year for those products. And so very soon, you'll start to see them on the roads around the world.
Wow. So the chip actually you showed at CES, I do remember you holding that chip.
Yep.
Where do I find that specification for that chip?
Should be on our website. If it's
there is. Okay.
If it's not, then shame on me. I've got some work to do.
So you have that. You have already talked to some of the potential customers who are already embracing it, start developing actual products based on the hardware you have shared with them. Is that right?
Yep, that is correct. All around the world, across all geographies.
What is this first generation chip based on? I mean, you guys are actually fabricating it yourself?
Yeah, so that's one of the benefits, of Intel. We own our own fabrication network. And so, during the supply chain crisis, we actually were able to produce more than our forecast, for our customers. So we never had an issue with Intel manufactured products, reaching our customers. So yes, manufactured at Intel fabs in North America and Europe as part of our globally balanced, resilient supply chain. Features are a mix of our high performance and low performance cores, which is an interesting architecture, fully instruction set compatible. What it means, if you have a workload, like you're just listening to music in the car, turn off the high performance cores, save energy, and run that workload only on the low performance cores. And somebody wants to play a game or doing something more graphically intensive, turn on the high performance cores to add more compute. So it's all part of the scalability aspects that we support. And the other thing that's really key about these products, as I mentioned, the origins of software defined in the data center, which really can't be said enough. And so these products support silicon features that have been developed over 20 years in the data center to optimize and accelerate software-defined workloads. In particular, we think about consolidation of workloads as you end up supporting multiple workloads across one pool of resources. And so, as we say, we think they really include the best of the AI PC combined with the best of the data center. And that's the right, magic formula, we think, to help automakers evolve their vehicle architectures.
Yeah, you already touched upon this, but I want to talk about this workload thing, right? Because you talk about the solving workload allocation. I mean, SDV is a key to solve workload allocation. So, I can think of so many different workloads in a vehicle. And you did mention a couple of things as an example right now, but tell me more about, technically speaking, what sort of workload are you talking about in a vehicle?
Yeah, well, I think at its logical end state, we're talking about potentially all of the workloads in the car. So certainly some may stay on microcontrollers for the time being, but over time, what automakers want to be able to do is consolidate workloads, reduce the number of physical ECUs, reduce the number of copper cabling, and all that. But I think there's an interesting, lesson that we learned in the data center space. So, rewind the clock back 20 years. And we're talking about the introduction of Intel Silicon VTX, Intel Virtualization Technologies. It was the first time that you had silicon support for consolidating multiple workloads in virtual machines. So you can do that in software, but you take a big performance hit. If you have silicon support, it's accelerated. And there were those that said, hey, well, wait, if we support the ability to put multiple workloads on one, CPU, wait, aren't people going to buy less CPUs? Isn't that bad for business? But there's something called Jevons paradox, which is an economic a law. Maybe law is too strong, but it comes from the world of economics. And what it says is that as technological advancements make the utilization of a resource more efficient, that increased efficiency actually drives more overall demand rather than reducing the demand that you need for that resource. And so that we saw that same pattern. This is from the 1800s was when it was originally coined. But in the data center, when silicon virtualization happened, people bought even more servers, not less, because the use of the technology was more efficient. And so I think it'll be interesting to see then what happens in the vehicle as we make compute resources more efficient because of consolidation and things like software-defined architectures. I think we might actually see overall compute in the car increase. So there might be fewer, say, sockets, but the total amount of compute, I think, could definitely grow over time, and we're starting to see some early signs of that.
Wow. So, but hang on here. When you talk about virtualization, I mean, it's like having one CPU do multiple things. And there's a safety issues, isn't there? I mean, if you're going to just do the software virtualization, I think some of the companies in Silicon Valley oversold the idea, the power of software, but I think there are some downsides. Can you touch upon the safety issue a little bit?
Yeah, for sure. And in the automotive industry, that's obviously paramount. And you're totally right. You can implement, before we supported Intel virtualization technologies in our silicon, you could do software-based hypervisor approaches where you could support virtual machines, but all in software. So is it software defined? Yeah. But there's a cost in terms of the overhead, sometimes as much as 20 to 30% overhead that you lose because you're doing software tricks because the hardware doesn't support the right features. But worse, now you've got not only a much larger attack surface because you need a bunch of code to do all that software virtualization, which we sometimes call para-virtualization, but you don't have hardware enforced separation of those workloads. And so now if you have, let's say, a safety workload running in one virtual machine, and then you have an untrusted workload running in a different virtual machine, if you've got that common layer of software para-virtualization where everything comes together, then you've got a common cause of failure and a very real concern around safety. So that's why we think to do software defined done right, you must have silicon enforced separation of these workloads, which not only significantly reduces the attack surface because you're pushing all that code essentially into the
Right.
silicon, but it provides the assurance of hardware enforced separation that doesn't allow untrusted code to get over into a trusted domain. And again, this comes from our experience of doing this in the data center for 20 years and why we have these features in our products. But these are things you don't do in a tablet chip, or phone chip, for example.
Yeah.
And so that's really a key fundamental difference in our mind.
Very good. Now I've saved the best question at the end. That is about your experience in China.
Well,
So you mentioned
I'm sorry, go ahead.
yeah, you mentioned earlier that you moved to China, but it's like tell us. I think there are a few things that I want to cover. This one, what motivated you to go to China and not just visit China, but move to China, which I think is really extreme, my personal opinion. But then second is what exactly are you doing in China, right?
Yeah.
And it's more specifically, I want to know what proposal you are bringing to Chinese OEMs. So give us a little rundown here.
Great question. So first, why am I here? Other than being on vacation this week, the reason why I moved to China for the next few years at least is because what's happening in China right now in the automotive industry, I think really represents the future of the global automotive industry. We're seeing China automakers take risks and take entirely new approaches to how they're designing the vehicle and the design life cycle. They'll do a new vehicle in 12 to 18 months, tops, instead of the traditional, kind of 4 to 5 years life cycle. So there's so much innovation and creativity and risk taking that's happening here. And so we want to be part of that energy and that excitement and help encourage and support, the industry here because we think these concepts and the kinds of vehicles that are going to be built here really represent a model for the rest of the global industry to embrace and adopt as well. So, in short, this is one of the hottest places in automotive right now, and we wanted to be at the heart of it. And since I run the automotive business, why not move me here? So I still have the same global responsibility to run the business and serve our customers around the world. Now I'm just going to do it based here while we also really lean in and learn from a lot of these new China automakers in terms of what are they doing and how are they thinking differently and how can we better support them, and our customers around the rest of the world with new products and concepts that will really help them evolve the vehicle architecture. So what we bring to them is a new choice. We hear over and over from customers that they'd like another choice, in the market. They want something that's more open, that supports open source software, that's an open architecture based solution. They want something that has more scalability, from a performance standpoint. And they want something that has more certainty from a supply chain standpoint as well. And so Intel, checks all those boxes. And so we couldn't be more thrilled with the support that we've got. We're growing teams all over the place in China, across Beijing, Shanghai, and Shenzhen to support all of the customer interest that we've got. So far, just a month in, it's been an incredible ride. So I can't wait to see what the years ahead, bring to us as well as the global industry at the same time.
Yeah. But I'm sure that your customers are actually surprised by the fact that you literally moved you and your wife to China, right? I mean, what sort of reaction you're getting from them?
Yeah, I think a lot of them are really surprised. But to me, it's a wonderful way to illustrate our commitment to this market and my sincere belief that we have things to learn, from the market here, and I think there's some amazing things that we can do with customers here to really figure out together, what does the future of the industry look like? And you can't do that, from the West Coast. You can't do that from halfway around the world. You've got to just be in it. I tell people, especially those who haven't been to China, post pandemic, if you've been before, you come now, totally different. You see dozens of vehicle brands on the road that you didn't see the last time, most of which you've never even seen or heard of. You see in-vehicle experiences unlike anything you've ever seen before, at prices that are also incredible. And so it's an amazing place, and through the pandemic, the auto industry here really continued to innovate and took a big leap forward. And that's why you see China automakers now starting to import their vehicles around the world as well. So for us, with our experience, selling products into global automakers, that's something else that we're all too happy to help them with as well. So definitely surprised, but then the next statement is, we're glad you're here. Because we need you, and we really want another alternative.
Aside from choice, though, what are they looking for? I mean, you meet with different companies, not only in China, globally speaking.
Mm-hmm.
What are the Chinese OEMs especially interested in Intel?
Yeah, I think first speed, and responsiveness. That goes without saying. They expect that probably from all of their suppliers, but that's part of why we're building a huge team here. Our philosophy is to put our engineering teams where our customers are, and not force our customers to dial back to the West Coast in order to get help. But beyond that, what they really want is that they're just not happy with the level of performance, that they're getting. We keep hearing they want more and more and more. It goes back to that, the Jevons paradox that I mentioned. It's kind of, we're seeing it in action, that even though these software-defined technologies, like virtualization, are making the use of the resource more efficient, that greater efficiency is creating even more demand for even more compute resources. And so they want more performance. They want to be able to choose, what hypervisors and operating systems they want. They want a more open platform where they can do their own innovation rather than us forcing them to use software from us. And again, supply chain is a concern for everyone around the world. And so particularly as they export vehicles, to Germany or to Europe, I should say, and many Chinese automakers, you read in the press, are building plants to build cars in overseas markets. We can deliver to them an entirely made in Europe or made in North America, kind of supply chain. So it's an opportunity for them to, reduce risk in their supply chain aspects as well. So
I didn't think about that. That's a very good point. That's really Intel's advantage, right?
Yeah.
I mean, it's a good, because I was just thinking that if you I was just thinking about Chinese domestic EV companies who are more inclined, probably, but I may be wrong about this, probably more inclined to use China's own chip companies. There are a lot of new chip companies springing up as well, and they're actually beefing up the performance, right? So why do they need Intel was my first reaction, but the whole gamut Intel can cover in terms of manufacturing, supply, design. That must be quite interesting to them too, right?
Yeah, it really does resonate. Some China automakers are in fact starting to ship more vehicles outside of China than they are in. China as a country is now the world's largest net exporter of vehicles. And for those that live in the US, you don't know this because you don't see the cars on the road, but it's happening, everywhere outside. But you're right. And there's one more thing I think that we bring too, is the software ecosystem. I mentioned the AI PC that Intel's launched recently. So that AI accelerator that's in the AI PC, Intel's making massive investments to grow a global ecosystem of software applications, frameworks, development tools, everything. We're using that same AI accelerator in our automotive lineup. And so customers of ours in automotive get to benefit from that same massive AI PC software ecosystem that Intel is investing in. So it's another piece that we bring, not to mention the open source ecosystem from the data center to do virtualization and all these things. So it's not just the silicon, the performance, supply chain, but it's also the software ecosystem that comes with, Intel architecture that we work very hard to create, around the world.
All right. Very good. Oh, this was so much fun, and we could still keep talking, but I'd like to have another session with you because I want to know more about after 3 months, what you've learned, right?
We'd love to. Anytime.
Okay. Well, thank you so much for coming to the show, and stay well, and good luck in China.
Thank you. Take care.
All right. Intel Automotive is committed to accelerating the automotive industry's successful transformation towards a software-defined, sustainable, all-electric future at scale. offering a best-in-class scalable product portfolio supported by regionally resilient manufacturing, all underpinned by decades of industry transformation experience.